Hello friends, welcome to this new video. Today we will see how to resize an image. Right. So in last videos we have downloaded the images and we were working on the Landsat image. In last video we have learned how to make the composite of an image. I think I have this composite image here. We can open it here. Anyway, it is giving an error. So we can make a composite image from scratch. Right. So what we have to select is we have to select the separate band images, not this one. All the TIF images we have selected and dropped it directly. Right. So let this load. Yes. So our images have been loaded. Now we can zoom to full extent so that we can see all the images. Right. So we can see all the bands have different kind of reflectance. So let us extend this so that we can see the bands. So here is band. Now to resize the image, we have an option here in the raster management, which is resize data, right? So first let us make a composite and then we will resize. So in order to make a composite, we just simply type here layer stack, or you can select it from raster management also. It is in the same toolbox, which we can see. Here we have raster management, resize data, then we have layer stacking here. So select it, import the files, just choose 432. I am creating a RGB, right? So okay, from here also we can resize the image, but now for now let us create the composite. Choose a image file name, let us say compo.tif. I'm giving a name compo.tif, and rest of the thing let them as it is, and we can change the resampling as per our convenience. Select OK and it will create. So our image composite is ready. This is how our image composite looks like. So if I like to zoom, we can zoom this, right? So when we zoom, we can see the spatial features. So if we want to resize this extent only and we want to save this as image, this will be called as resizing the image. So resizing, what does resize mean actually is, let us look for this. So here we go. Yes, here mm, this generative AI gave us the definition that, let's say, is image resizing is a key part of remote sensing because the level of detail image is dependent on the spatial resolution of the acquisition sensor, right? Which means we want to, if we want to resize the image as per our convenience, we can choose what extent we want to view in the image. Then we can go for image resizing. So image resizing may be upscaling and downscaling, but without changing the scale. If we want to just crop the image, then that we can do from here, right? So let us zoom this to full extent, and now, okay. So this is our composite. We can change the RGB like 432 is RGB. The image will show in RGB, right? So here we have the actual image, how it would look. Now, if we want to resize the image, just go to the raster management in the toolbox. Then inside this, just go to this resize data. Just go to the resize data and select this image. And here we have option of full scene. So we do not want to see the full scene. We want to see the spatial subset. And here we can choose in what when we want to curtail the image, right? So I am going with all the bands, which means I am choosing the composite, and in spatial subset we will either give the pixel number from which pixel to which pixel. We have this much pixel in samples and in lines. Basically, lines are the vertical grids basically, or otherwise we have these options. Like this is the vector file we will discuss in upcoming videos. We can provide this ROI, or we can map it, or we can simply go by image. So I am selecting it by image. Just choose image, and here we have a red cursor. Just select it by the edge and choose the area you want to view in your image, right? So I want to view this portion only. So let us see what will happen if I choose this. Like I have selected 728 cross 728. So this will be the pixels basically, which means mm, if we make grids equally sized grids, then we will get 728 out of 7 into 728 matrix, and each grid of the matrix will have different DN number, which is basically the subset. Here we can choose the band. Oh no, it is not selectable. It is also giving the same option, this ROI and EVF. Now we are ready to go. Just click on OK button. So now whatever pixels are there, this is the subset domain. Then if we click OK, it will create a subset, a new file. See, it will create 728 pixels with a X factor of 1, meaning we have not scaled the image, right? So in this time we are not scaling. In next case we will see scale by scaling it, right? So just give an image name, like I am giving compo sum meaning subset, not TIF, right? Just click on OK and see what happens. So here we go, we have the image. Now we can actually zoom the image. See, if we want to see the full extent, so this is the scale basically. So we will need to zoom to view this. So this is the image, we have made this and this is saved in our direct. Now friends, let us see what happens if we scale the image, right? And that scale option we have seen in the previous step. So for this we have to go to the same resize data again. We will again select the composite, the entire image. Then we can also choose the option to set the dimensions. Like let us first set the scale factor. If we want the image to be 3 times in larger, magnified, so we need to set the x fraction and y fraction as well. Otherwise, we can input the desired numbers, right? And with this, let us assume that we want it in the coarse resolution. We want pixels of 10 meters, right? So just give it 10 meters, then it will divide by 3 because in 30 meter grids. Let us open the paint. Let us understand this with the help of paint. So earlier we have an image like this, right? So this width was 30 meters, and now we have divided it into 10 meter width, right? 10 meter width and height, 10 cross 10. So it will be like this. So in this much portion, we will get 3 such pixels, right? This is why the factor changed to 3, right? So otherwise, uh, yes, let it be. We can also change it as per our needs, but yes, now just choose, give a file name like compo.fact.tif and just click on OK. We have options to compress, but we are not compressing it for now because compressing will lose some. On compressing, we will lose some. Actually, friends, we ran into some error, so I'm just opening those files again. So, friends, I have created another composite as earlier I have created. Now I am inside this resize data parameter, which is basically here. Here I have chosen this composite file, then spatial subset. So in spatial subset, I'm again selecting a region, say 1000 cross 1000, and let us move this to center. So this is our image spatial subset. Now we will just click on OK, and we want to create it on our up composite. So we will just click OK, right? So when we want to change our X dimension, so if we want to upscale, let's say we want to increase the pixel size, say 40 meters, right? In that case, this fraction will be adjusted accordingly, which means uh, if this image is like this, if we have some pixels inside the grid of that image, so this is an initial condition, right? So suppose if some light falls on it and it get focused on this point, right? So uh, so suppose light is falling on this image and it get focused at this point, right? So in that case, if we see at all the solid angles that is subtended, suppose in this portion we will have the same image, but what will happen in this case, our pixels will be relatively smaller, right? So suppose if we have this pixel and if we compare this with this, then this will be relatively larger and this will be relatively smaller by some fractions, by some factors, right? So this is the condition. If we upscale, then in that condition, our image will become more larger. If we go beyond this, our image will be like this, and here our pixels, whatever pixels will be here, this new reference pixel will be larger in size. This will be like this much bigger. So it will uh, adjust accordingly. So if we give this as 1, if we give this fraction, that factor as 1, then it is obvious that it is going to be of similar pixel, right? It will be curtailed, but it will have similar size of pixel. Otherwise, we can adjust a fraction, like if we want to upscale, like we want to double the pixel size, like this one, then in that case we will provide, suppose this is factor 1, then we will provide 2 or some larger factors, or in this case we will give some smaller factor. So this will be the case of downscaling. This will be upscaling because we are increasing the size of pixels, and hereby we will lose some details basically. And in downscaling we will get same amount of this data. Suppose this is the data, the same amount of data in this pixel, so we will get more amount of detail in same pixel, but here we will get same data but in larger pixel, so we will lose all the details, right? So more space inside that larger pixel will not consist of data. It will concentrated in smaller portion, but as we zoom zoom out, basically the details are more concentrated over a smaller region. So this is a concept. So either we change this factors, or either we change this pixel size, right? They will be adjusted accordingly. Suppose we want grid size of 10 meter cross 10 meter, then we will uh, enter it and click on OK. Then it will be adjusted accordingly, as I've explained you. Because in this case, suppose we have just 10 meter, 30 meter data, and if we select 10 meter, then we will get 3 pixel of 10 meter. So our factor will be 3, right? That is basically, we can see here. So the factors have changed accordingly. Otherwise, if we enter 50, say 50, we want to upscale, then this factor will be changed accordingly. This became 0.6, right? Again, I want to downscale. Basically, in downscaling, the memory taken is more because it is difficult to downscale. We want to put same amount of information and concentrate it over smaller region. So I'm just clicking on set dimension. I am trying to put the same detail in 10 meter cross 10 meter grid, right? 10 meter cross 10 meter. Here we can select whatever suits us, and then we will click on compo resize. Dot tip. Here we go. Just click on OK. It is completed now. So let us see the details. Let us first see the details of this composite. So to see the details, just right click on it and see view metadata. So inside view metadata, we will see the spectral information, the extents, and then we have map information. Here we will get pixel size 30 meter cross 30 meter, right? And type is raster, and further details are mentioned here. Now, as we know, we have compressed this image, basically resized this image, and we made the pixel size to be 10 meters. So let us zoom this image. This is the extent, and right click on this image, and here we will see this view metadata, coordinate system, map information. Here we can see that the pixel size of X is 10 meter basically, and this is our swath width basically. So 10 meter cross 10 meter is the pixel size in this image. We can edit the metadata manually if we want to put some more information. Additional information can be incorporated inside it. So in this case, we can see the pixels are quite smaller, and the more amount of details is contained inside this. So if we want to see the same thing like this image, I'm zooming this to this extent. So we have no composite yet. So you can see this feature, and now I will enable this composite and make this resize portion invisible. Then in this case, this feature is of relatively larger grid, so the features will be not very clearly visible. Okay, the color has changed because the band combination is altered. So we need to give band 4 as R, 3 is 2, then B as 2. Then our image comes in true color composite. So this is the this way we have downscaled it. Otherwise we have also options to upscale it. Like I'm going to upscale this image, and we will select a spatial subset. The process is similar. We can select a region basically. Like I have selected a region, and here we have to click OK, and then we will click OK. Here we have to click and change the pixel size. Like I'm going to give 100 meters. I want to upscale basically. We want to lose some details. So choose. I'm just giving a name upscale dot paste, right? See how quickly this image has the image processing has done in this case. So we want to view full extent. So here we can see the pixel size has details has been loosed, right? So we cannot identify features as we were able to detect the feature in previous image, right? With previous scale. So we lost the feature, and this has relatively larger grid size. Here we can see the details of this image in metadata. So here we have map information. We have 100 cross 100 meter pixel size, right? So this is the process of upscaling and downscaling. So friends, now the question is why we do need to do this upscaling and downscaling thing. So the answer to this is for the comparison purpose. Suppose if some image has, uh, I'm not drawing the entire grid. Suppose some image has this scale, this grid, and some image is relatively finer than that. This has, say, grid size of 5 meter cross 5 meter. This is, say, uh, 30 meter cross 30 meter, right? So we cannot actually compare this. We cannot compare, right? So in order to compare these two datas on the images, basically we need to come on the same scale, right? Scale it. Scale should be similar to measure, basically. So for this, we resize the image and we make both of the images on the same scale, either by upscaling one image. Like if we upscale this one, then we will lose some of the details from this image to reach this point and this point. So we get similar resolution image in that case, but it is uh, not that easy in practice actually, right? Downscaling take a lot of computational power. Basically it is done through the interpolations. So in this case, if the grid size is same as this one, then we can actually compare, right, these two images. Say this A, this one B, this one A prime, this one B prime, and similarly, if this is the case of the image when it is downscaled, the first image is downscaled. Otherwise, in second case, no, second image was upscaled basically. So here we have lost the details from this image. In second case, what can be done is we downscale this image. This was upscaled in first case, and in second case, if we downscale this, then we will concentrate. So more amount of detail will be identifiable. Basically, features will be easily identifiable in this case if we downscale this, because the pixel size will become smaller, and the smaller pixel size will contain more amount of uh, basically same amount of data in smaller size, so it will be more concentrated. So in that case we also would be able to compare, right, these two images. So let us see which comparison is better, upscaling or downscaling. So friends, I searched for this technique. Here what people write is which one ruins the quality of pixel. So upscaling doesn't add information. That is what I have told you. Same amount of information is less concentrated basically. It just put a more pixel between the existing pixels. So arguably it doesn't lose or gain pixels. So we are not losing or gaining the pixel. We are just increasing the size of pixel. We are just zooming in. Okay. Also, uh, using upscaling, you gain download speed. Oh no, this is something different. Now, here one person write downside where upscaling stretches the image to fit the resolution you are displaying at. So it will be better to upscale the image which is at lower resolution because it will not lose the details. Basically, it will basically stretch the same detail over a larger pixel, right? So such that in that case, what will be feasible is if we upscale the first image which has finer resolution, then it will stretch the information, and another image that has same scale of information, then in that case the comparison is better, right? But here we get a definition and difference between resize and upscale. Using resize will result in slightly lower resolution. The photo want to be started with. You are essentially exchanging the quality of image. So what we have done when we gone through uh, this process, this basically this resizing process. In this case, we lost some detail that we have seen. When we upscale, we lose some details. Basically, uh, in technical terms, we lose some details because we it is difficult to identify the features when we upscale. But in theory, we do not lose the quality of image because same amount of information is getting stretched over a larger pixel. So, according to theory, we do not lose the pixel, but in practice, we have seen that uh, we lost some mm, data. We are not able to identify the features basically because when we zoom it, see and see this one image, see in which image you are able to identify. This is basically the composite image, 30 meter resolution, and also see this image here. The images have more pixels because we have basically downscaled the images. So here you can see how clear the pixels are, right? And there are multiple algorithms. Uh, when we resize the image, when we upscale, it takes lesser memory, but when we downscale, it takes large amount of memory, right? So one such method for downscaling is bilinear interpolation, right? So this is basically the method of interpolating uh, the corresponding value of digital number in a pixel as by interpolating from the neighboring pixels basically. And I came across a website that explains it very well. Let me show you. So friend, I'm just opening this post. This is from Washington State University. This is a PDF named Interpolation in 2D. So in 2D they have explained this. These are the corresponding values. There are different type of interpolation. Basically, first they have introduced this two-dimensional interpolation, assuming that and this z is a function of x and y coordinate, and this neighboring x and y values are given by this, like xi is unknown, x1 is known, and I is the number of steps or the length it is known, and delta x is the distance between 2 points. So this way. Second one is bookkeeping. This is also a method. Discretization. You can read it. I will include the link inside the description of this video. Then nearest neighbor. Then comes this linear interpolation. Basically, linear and bilinear interpolation. But I have some another website. Let me show you. Yes, this blog, this GitHub page basically explains the bilinear image resizing in very depth and in very easy way. Like they use the section formula to determine this in 2 dimensions. In 1 dimension, basically in x. Suppose this is the initial pixel, this is the final x pixel. Suppose b, and the distance between them is this x minus a plus b minus x. Then they applied the section formula to get this value of x. This is the dn number, suppose, and this is the coordinate value. So here the dn number is missing, so they get this dn number by section formula, and they replace this w by x minus a and v minus a, such that this becomes this w, and this becomes 1 minus w, right? So this is 1 minus w times a plus bw, and using this they have also given the formula, and using this they go for bilinear interpolation. Similarly, they get the value of this by, and using x and y they interpolate the value of z, what we call as suppose we can say the dn number and some this unknown xy coordinate that we wanted to find. So a formula comes like this. You can explore this. I will include it in the description. I will include the previous link also. So this is the formula to calculate the z value at some x and y pixel. So questions can come in the format like when you have these all three values are there. You have these values. You have this xy coordinate also, and you will need to find this z d number, right? So in that case, we can use this very simple to calculate the z value, right? But in this software, we have this interpolation fitted. We do not need to manually calculate the d number for each pixels, but to understand the theory, to understand the concept, it is important to go through the process. So I have already discussed this bilinear interpolation. This is very easy. You can try, right? Thank you. Now let us meet in the another video. Thank you. Please subscribe this video. This actually motivates me in making new videos. Thank you.